Okay, so the power rule times the front and the top, lower the exponent. So this one is times the front and top, we get 140 x to the 6th. Okay, next, if our function, we'll just say if our function is some function plus some other function plus some other function, the derivative will just be the derivative of that function plus the derivative of that function, etc. Okay, so nothing really new there. This is going to look way more complicated than it actually is. Okay, so the derivative, if I have all of this, so this is, we've already done this, then our derivative is, what do we got? 21 x to the 6th. Should we rewrite this one before we derive it? How would I change the root of x? To the 1/2. So the derivative is 4x to the -1/2. And what's the derivative of just the whole number 6? 0. So that's it. Okay, here's where we get something new. Okay, so if your function would look like this, so something times something, then your derivative is the derivative of this times the original that plus the original that times the derivative of that. So you're going to have to take turns doing the derivative. Okay, so here's an example. So here's the two separate things. Okay, so I'm going to derive this one. So 2x plus 8 times, and I'm going to keep that. I'm just going to rewrite it. Plus, and now I'm going to switch. So this time I'm going to keep the first one, and then I'm going to derive the second one. So 3x squared plus 14x plus 2x to the -1/2. Okay, so in example 2, this time I actually have 3 units. So what do you think we're going to do that's different with 3 units? So we're going to separate into 3 chunks, and you're going to take turns every time one different thing has to get derived. Okay, so first time through, I'm going to derive the first. I'm deriving, and then I'm going to keep. So that's when I derived the first one. Plus, so now on this turn, I'm going to derive the second unit. So I'm going to keep, derive, keep, plus, I got to do this one more time because I have 3 units. So on the last one, you're going to keep, derive. So just take turns alternating. You're deriving a different thing every time. So kind of, if you wanted to think about an idea, this is kind of like an idea that I did. Do you see what I did? This one I derived the f function, here I derived the g function, and here I derived the h function. Just taking turns. Okay, so now the quotient rule. So the quotient rule, kind of like the product rule, we're going to derive times keep. Instead of an add, what do you think I'm going to do? Subtract. And then keep, derive. Okay, so that's almost like the other rule. Take turns. But this time, we're going to divide by the g function squared. Okay? And sometimes, I don't know if this looks too complicated, it's okay to think about it kind of like this. If that helps your just logic, just take turns driving. Okay, here we go. What is it going to look like? So I'm going to derive this. So 2x plus 7 times the original bottom subtract the original top, derive the bottom. How are we doing with our derivatives? Are we keeping them good? All of that is going to be over that function squared. Okay, and there's going to be, I'm never going to ask you to simplify something like this. That would be crazy. So this is it. Okay. And the chain rule. Last one we'll do today. So the chain rule, so if your function looks like this, and the u is meaning you have like a bunch of stuff in there. You don't just have an x this time. You have like a group of things. Then your derivative is going to be kn, right? We times the front and top. U to the n minus 1. That's the same as the power rule. Then we're going to have to times by the derivative of all that stuff. Okay, so here we go. Number 1. So the front is a 1 times a 10. So 10 of the stuff to the 9th. Okay, that's what we've been doing before. Times the derivative of the stuff. So 12x third plus a half x to the negative half. And that's it. So that's called the chain rule because you're like attaching something. You have to do one thing and then attach another thing to it. Okay, number 2, are you okay if I rewrite? No? Yes? Good? Sammy, why are you shaking your head?
What?
You're like, This one?
Oh, no.
No, oh, okay, it's good.
Yeah, I'm good.
Okay, I'm going to rewrite this. So x squared plus 9x to the, what do you want to put up there? How do you rewrite that as just an exponent? 8/5. It's the 5th root, so that part goes on the bottom. Okay, so I rewrote it. So now let's derive it. So what's the front times the top? So 1 times 8/5 is 8/5 of those to the, can you guys go down? How do you go down 1? 5/5 is the same thing. So now we're at 3/5 times, now you still have to chain it. You got to do the derivative of that group. So 2x plus 9. Okay? So it's kind of just like adding on for what we know here. Okay, now I'm going to tie a few things together. This one's going to get long. Okay, ready? Front times top equals 10 of the group to the 9th times the derivative of all that stuff. How are we going to derive this thing? What are we going to have to do when we derive that? We're going to have to do the quotient rule. Okay, so when we derive just that part, quotient rule. Okay, so how do we do it? We derive the top, so 10x, right? 10x times the original bottom, subtract, now switch, so original top, derive bottom, all over the bottom squared. I will definitely not ask you to simplify something like this. Okay, that's it. Okay, but this is just for you to see that on the chain, now you also had to do a quotient rule. Okay. Number 4. I think I would like to rewrite this. How would I rewrite it? I'm going to do a -6 because now I'm going to do the chain rule with that. Okay. Front times top is -48 of those to the -7 times the derivative of that inside stuff. So 2x plus 3. That's it.